In this problem, we're going to study factorials. So we do that through an example. Suppose we have 3 marbles. 1 red, 1 blue, and 1 white. Well, red, white, and blue. Okay. And how many ways can we order the marbles? Okay, so let's just look at, okay, well, what happens is you have the first position. So let's say starting left, right, and in the first position, what you can do is you can either put a red, a white, or a blue. So that's going to go in the first space. And in the second position, or the second space, you can put a red or a white or a blue. And supposing the first one's a red, you can put a red, white, or blue. Oh, hold on, got that wrong. The red's already been used. See, so if the first one has a red, there's only the white and the blue left. Now over here, if the first one's a white, there's only a red and a blue left. And if the first is a blue, there's only a red and the white left. Now, if you have red and white, so this is the third, you have a red, white, there's only one thing left, is a blue. If you have a red, blue, there's only a white left. Now here we have white, red, there's only a blue left, right, blue, there's only a red left, blue, red, there's only a white, blue, white, there's only a red. So you can list these. You have RWB, RBW, WRB, WBR, BRW, BWR. Okay, now the thing is, the question was how many are there? There are six different ways to order these. These are called permutations. Permutations are the different ways you can order. Here I'm using colors, but pretty often you would just take the numbers 1, 2, 3, and you would order those numbers. Okay, now how are we getting this? Well, we write 3 factorial. And 3 factorial is 3 times 2 times 1. So why am I even going into all this trouble here? Because I'm telling you what an application of the factorial is, the number of ways that you can order 3 objects. The number of ways to order 3 objects is 3 factorial, which is 3 times 2 times 1, which is 6. So, okay, what is this 3? Where does the 3 come from? That's our first toss, or in our first position. We have 3 different paths we can go down. But see, once we went down the red path, we only have 2 more we can go down. We can only go white and blue. And then once we've gone to the red, white, then there's only blue left. So there's 3 paths on the first position. Then the second position, there's only 2 paths left, and then finally you have 1. And you multiply those out. So let's go ahead and focus mostly on evaluating factorials. So we already did 3 factorial. Let's do 4 factorial. 4 factorial is 4 times 3 times 2 times 1. So, I mean, it's pretty clear that that's going to start to get sort of difficult. If we put, say, 5 factorials, then this starts becoming sort of a large number. So it turns out that it becomes really big. Like if you looked at 100 factorial, it would be just some really large number. Now, these all can be done on the calculator. And the calculator I'm talking about is a TI-83. So for TI-83, this is what we're going to do. We're going to write down the number 5, and then we're going to go, here I actually have the TI-83 right here. We write in number 5, and then we press the button Math. And then after you do Math, you're going to go over to PRB. And then you scroll down to 4, which has that factorial, which is an exclamation point. And you press Enter. Well, I did that wrong. Let me try it again. Okay. I'm going to enter the number 5. I didn't do that. That's my problem. I put 5, and then I go to Math, and then I toggle over to Probability, and I go down to 4. Okay, so you have to put the number first in, and then you do 4, and then factorial, and then enter. There you go. So, okay, so that's what you do on the TI-83 calculator. There's just a, so I mean, you could, let's do a bigger one. So suppose you did like 15 factorial. This becomes sort of a large number. It's 15 times 14 times, and what happens is that I can start doing dot, dot, dot just to mean I don't really want to write them out. But on the TI-83, I can do 15 Math, PRB, and then I do number 4, which is this guy here, and then enter. Maybe I should have written enter before. And the thing is that these numbers get really large. So you might try, for example, putting in 100, trying to evaluate 100 factorial. So the answer is going to be 1.307674368 E12, and this means 10 to the 12th power. So this is a really big number. Okay, and let me just point out that, by the way, 0 factorial is 1. It's just the way it's defined. In some ways it doesn't seem to make sense, but we want to have 0 factorial. And for factorial, we only use positive integers.